Well, I'm back, and we're going to give this layout another shot. We're going to drill 2 new holes in this. But first we're going to lay it out a little bit differently, hopefully a little bit more accurately. What I've done differently is a couple of things. One of them is I've milled the bottom of this now because it was not cleanly machined before. It was very quickly fly cut, and the finish was something like this. I suppose it was not indexed from the side like I'm going about now. I'm going to scribe this. It's going to be a little bit off center since I can't be on center anymore with don't want to confuse these holes for the ones that I want. In the last video, I mentioned that there were these 2 tricks out of machine shop practice, and one of them was twirling the hand prick punch. And I really couldn't find, not only could I not find a hand prick punch like I saw in the book for sale, but I couldn't find any pictures of this certain kind of prick punch anywhere on the internet. Maybe I didn't search hard enough, but what it looked like, and here's a picture of that page from the book. And what you will do is you'll push, this was a masonry drill bit. You'll push the punch with your hand, and it will spin. Your hand will spin the drill bit, and that will be the very beginning of the punching. Then you would find that tiny little punch mark, and then punch it with a prick punch, and then punch it with a center punch, and so on. So here we are with the Redneck shop microscope, and I'm using the screen just as much as a tool. And here we are with my scribe, and I can see it very clearly. I'll lift up the scribe and move the microscope out of the way. It's a microscope, huh? I'll move it back in place, and let's see how we did. So, stop looking down the microscope for a moment, and this is what the motion of the hand prick punch is like. Kind of like I guess like a, what do we call it? A bow drill, where you're making fire with a bow and a stick. Anyway. Here goes the second one now. Here comes the scribe, and that's right in the center. Yes, it is. And I'll move the workpiece out of there and twirl it around. Okay, that looks good. Maybe just a little bit to the right. And I wonder if I can move that over just a touch. I'm going to bring in my homemade deal, which is probably not all that bad, because it's got, like I said, I couldn't get it to be as fine of a point as the scriber. So this will hopefully just largen it up a little bit, I hope. Alright, that looks good. I was not okay with these original 2 holes being 5/1000 off-center like how they were. But I took the time, got a little creative, and I got them where they needed to be. I'm not about to say that it must be 4 1/4 dead nuts and then change my mind about that and say, oh, well, I guess it's alright. No, it's going to be like I said it is. Now let's go over to the mill. This aluminum part to the little drill is free spinning, and I can grab, I can turn the drill on, and I can grab this safely, and I can get my sensitivity back, because if I was to drill this with the knee, I would have no sensitivity. We're going to ream it 1/8 of an inch and then try that experiment with the dowels one more time. Seems like we've been here before. Well, just like last time, we've got 2 1/8 inch dowel pins. We're going to put these dowel pins in the holes we just made and measure at either side of them. And I'm looking for 4 inches 3/75 on either side of these dowel pins. We are exactly on 4 inches 3/75. I'm not going to show you the calipers. I could, but what I have here is a stack of gauge blocks, 4 inches and 1/8, which would be what comes between the 2 pins. And so I'm going to put these between the 2 pins. They should go in with a little bit of drag. Well, yes, it does go through. And I will swap this 1/8 of an inch for, well, do I have a 126? I do have a 126. So let's ring this one on. And I suppose then that this stack must not go through the pins. It does not go through the pins. I cannot wiggle it in between them. So that confirms what we measured. So in spite of that milling machine wobbling like crazy, giving me upwards of 15 thousandths run out, we did our layout a certain way, and we were able to make this thing accurate as we wanted it to be. I'm ready to drill and tap the jig plate now. I've gotten lucky in that I was able to use collets for some of the larger sizes of drills, larger being like 5/16 and such like that. because then I have less run out, less parts spinning, creating their own run out. The way I'm locating these holes is I'll loosen the straps, I'll let the part float, spin the drill backwards a little bit and just let it center itself over that hole. There we are. And now I'm ready to tap these for 3/8/16. Here is the strap that will go over the parts when they're in the welding jig. I didn't show that, but it was more of the same stuff from what we did in the main plate, sort of base of the welding jig. Here is our drawing of the screw post. This is what the parts are going to sit on when they're in the jig. The whole idea of these screw posts is to prevent the draw when the part cools and prevent distortion, essentially. I still have to remake this part, but I'd like to put it here just to show you what the big idea with the welding jig is. So the screw post will go on here, and the weldments will go through them, and the strap will go on top of the screw posts. There will be a spacer here to clear the distance, and we'll have these nuts on them. I don't really think they'll be doing much more than just keeping this from floating off if suddenly there's no gravity in the room. Anyway, these will go here, and then the part I'm calling the webbing will go between them, and the webbing will get welded to these sleeves. Well, that's all for this video. I hope you've been enjoying it. In the next video, we're going to be making the webbing. We're going to be welding the webbing to the two sleeves. And if everything goes well, we'll be boring the sleeves out for the bearings and the overarm. I'll see you later.